Now see here characteristics of PN junction diode. So we have seen the biasing of the diode. So now we will be seeing here characteristics of the PN junction diode in forward and reverse bias. Basically we have to see your IV characteristics or IV graph for the PN junction diode in both the cases forward and reverse bias. So let us see here. First, if you have taken like this is a diode here, PN junction diode. This is P side, this is N side. We connect here with a battery, variable battery over here. This is plus, this is minus. Across this diode here, a voltmeter is connected, plus minus. And now, because and here and a milliammeter is connected here, plus and minus. So this circuit is actually here known as here this case. It is the correct circuit for the forward biasing of the diode. Now, if you look at the reverse biasing of the diode, you will be seeing here, if you have taken PN junction diode like this, and here we take negative terminal of the battery. In this case, we connect a voltmeter here again, but this is the plus and minus. And in this case here we will be seeing here, this is called here negative and this is called here plus, this is microampere. This is a variable battery over here we have got. In this case, these two circuits, you can vary this voltage from this battery and see the nature of the graph drawn between this V and this I. Similarly here in this one, keep on varying this voltage and you will be drawing the graph between V and I. In this case the current is reverse and that is here in microampere it is measured, it is very small in magnitude. In this case current is in milliampere. So now let us see how do we get the graph here, what is the nature of the graph in this case. So the nature of the graph we will be getting, it is like this. If you have taken V to this side, I is over here. So for the forward biasing this is 0 and the graph becomes like this something here. This voltage, at this voltage where the current, small change in the voltage, but there is a rapid rise in current. This voltage is known as knee voltage. We call it knee voltage. And this is here I, but it is here in milliampere. So in the diode, PN junction diode in forward bias, you can look at the graph here. It does not obey Ohm's law actually here. Initially when the external voltage applied is less than the barrier potential, there is no much rise in the current, very small. And just after that, here if you do the small increase in the voltage, input voltage, you will be seeing there is a rapid rise in the current, there is exponential rise in the current, and this is the graph here. So this is a device actually which does not obey Ohm's law, and in this case also you will be seeing here resistance does not remain constant and resistance is variable. So we define the resistance here, that is called dynamic resistance, or you can say here AC resistance. So in this case we take the resistance is here dynamic. Now look at the graph for the reverse bias. The reverse bias graph is something like this is here. In this case the current is this side, but that is in microampere, and voltage V is this side, that is called reverse voltage. And you see here when the reverse voltage is increased, there is a very small rise in current, because that is due to the minority carriers, it is small in magnitude and measured in microampere. But at the certain voltage here there is a small rise in current voltage, but there is a large increase in the current. This voltage is known as here breakdown voltage. So this is here the breakdown voltage. So this is called here characteristics of the PN junction diode. If you are taking here any two values here, the dynamic resistance can be defined. Dynamic resistance can be defined here delta V upon delta I, that we can take from this graph also here. So that is here delta V upon delta I is dynamic resistance. We can also take here as the static resistance. See here, an ideal PN junction diode has no potential drop across the junction, and it means its resistance is almost negligible, and in the reverse bias it offers infinite resistance below the breakdown voltage, and it does not allow any flow of current. Ideally we can assume like that.